Hello, Algebra 2. Welcome to another video lesson with the Soundster. Today we will be continuing on a video that we've done last time, and what we're going to do is we're going to continue looking at the key features of the square root function. We're going to reinforce. I only talked about them translations last time, but let me introduce you and just jog your memory about some other ones like reflections. And then we're going to write the function of a transformed square root graph. That's going to be a goal because that's just like, hey, can you write the equation? We'll see if we can get through all that today based on what we get through. So let's get started. All right, class. What I would like for you to do is go ahead and hit the pause on this video based on this graph of the square root function. And I'm going to tell you that this is a square root function. So according to what we have over here, okay, I know it's hard to tell where the endpoints and the curves and stuff are, but give it a try. And then once you're done with that, I'm going to write down what we know. All right, I'm ready to start going over this, folks. Do you remember about these big ideas for these domain and this range? Let's check this out. We know domain is side-to-side motion. Okay, we know that this is being controlled by the x value. But how do we always read graphs? We read them from left to right. All right, so when we do this, let's check this out and see what we got going on. Okay, slide to the left. How far to the left can you go? You can get down to 4. And then slide to the right. How far to the right does this function go? Forever and ever and ever. So we're going to do infinity. But you don't just give me 4 to infinity. I need more information than that from my Algebra 2 students. Is this 4 included? Yes, it is. You see how there's an endpoint that this is the closed circle? We're going to use a square bracket, okay? When I'm talking about, hey, how did you know to use a bracket on there? And then the parentheses is going to be on the infinity. Whenever you have a closed circle, something that is included inside of the graph or on a solid line, if it is included, right, that's going to be using your square brackets. If it is an open circle, meaning not included, or if it's an arrow because it's going on forever and ever, like an infinity, that is going to be not included. In this case, we use the parentheses to say non-inclusive. All right, just as a refresher, but then what you know about that range? We know range is going to be up and down motion, but how do you build a house? We know that's with the y values, but how you build a house? Do you build the floor first or the ceiling first? You build that floor, so how low can you go? Can you get down low to your floor? Where is your floor? How low can you go? You can get down to 1, and that's your end point. You see how this is the very beginning of our whole situation? That's going to be our end point, so that's going to be a coordinate point, x comma y, as an ordered pair. So here, this is 4, comma 1. I actually think that this is the easiest question on a check quiz, or one of the key properties that we have over here. Okay, so when are you going to talk about the range? My bad. I went off track. Let's get back to range. You get down low to your floor, so you always talk about your minimum first, and then you do your maximum. So how high can you rise? Can you touch the sky? We're going up forever and ever, so this is going to be from 1 inclusive to infinity. Miss Stone can't hold no infinity dollars in her bank account. She on the teacher salary. But if you know one, let a teacher know. Okay? Now, increasing means that remember, these two, increasing, decreasing, you talk about the x values. You want to remember that we're always reading the graphs. Read graphs from the left to right. The order does matter. Okay? So here, start all the way on the left and look, is this function increasing? Is it going up? Or is it decreasing, going down? It's increasing. Is it always increasing or does it change directions? Bam, this one's always increasing. So here's the thing. You give me the x values over the whole thing. This is really easy. The whole thing is increasing. This means that it never decreases. So we got NA for not applicable. The really nice thing about the square root functions, right? Because this is the square root function, is the fact that it's always all increasing or all decreasing. So just as, so see, right here, square root function. I even wrote it down for you before I remembered it was on my flip chart. We got this is the OG, the parent function, the one that started it all, okay? We got all the factors, and then check this out. I need my babies to know how to handle these. You need to know what the key points are, okay? Oh, you know what? I marked that in orange because I had this silliness sound. All right, you see these? You need to memorize these key patterns. So if you have this written down or you're adding it to your notes, we need to know what the original table is. We got x values and y values. Now the square root is the inverse of the square function of the quadratic. So what do we know about from what we learned on inverses? When we are looking for the inverse, we switch the x and the y value. So what you would have done for all the positives for the quadratic, 1, 2, 3, we just switch it around, okay? 0 squared is 0. Look at the way Miss Son is setting up her table. The 1 squared is 1, 2 squared is 4, 3 squared is 9. But if I'm reading it going forward for the square root function, check this out. Listen to the way Miss Son is and watch her pen. The square root of 0 is 0. Square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. All right? You with that? You good? Because here's the thing. If you know this original pattern, when we do some of these translations and these other motions, you don't need to worry about it. If you know the original pattern, then I don't need to spend all this time calculating, plugging in values. Okay? I'm going to show you. We did this last week. Do you remember we were just talking about the original parent function? You see that? From the beginning, square root of 0 is 0, square root of 1 is 1. From the beginning, square root of 4 is 2. And then last week we talked about translations when we are bumping them or shifting them. Translate, that's like a slide. But don't you give me the word slide or a shift. We are big boys and girls in the high school. Come on. So over here, you see, inside of the symbols is opposite land. X's are crazy. They don't always do what they say they would. I mean, let's be real. I've had some. There are some X's that don't have to be crazy, but inside here with the X, they always do the opposite that they say. So this one is actually going left, even though we see the plus sign here. You see in H of X how the plus one is on the outside of the symbols? That's important, fam. This means it's going up. So when you see the square root symbol, when you see the cube root symbol, when you see the fourth root symbol, this is a family called radicals. These are radical functions. So those are called radical symbols. All right. So here is me just practicing and follow my jam on all them properties because we know about the domain range, increasing, decreasing, and endpoint. All right, all right. Now this is something we discussed last year, okay? This is Miss Sohn's not so mathematical way of saying horizontal translation. It's like inside the group or symbol with the X is opposite land. You just go in the opposite direction. Vertical translation, good. We can get dilations if there's a number in front or if A is 0. Just kidding. If A is less than 0, this is a reflection over x-axis, all right? So if you were in class with me, I had a poll. So you just tell me what these two transformations are, and then we're going to work this out. As a video, you may pause right now and see if you can list out the two transformations that take place for this square root function. Well, I hope you notice, okay? When I did these Zoom polls during class, I'm going to let you know, okay? Majority of the class knows the outside number is going down. That one was very good. So we know we want translate down 4 units. Isn't that why Miss O makes you write down notes so that you can flip back at it and not try to remember in your mind? Remember what happens? What does X control? What kind of motion? side to side, horizontal motion. But inside of the symbols is opposite land. So if you see the plus, you're supposed to go to the right, but we're really going to make a left. So we're going to say translate left 3 units. Now I'm going to show you something, okay? These two transformations will tell you where your end point ends up, okay? So from the origin, remember, x is horizontal motion, y is vertical. From the middle, we're going to go down 4 hops. 1, 2, 3, 4 hops this time, and then we're going to go bump, slide to the left. 3 hops this time. 1, 2, 3. Bam, baby. That's your beginning. We start with the end point. This is the easiest one on the quiz or on the problem. But you know what? Miss Sun be messing with you. Down 4 is out here on the vertical. Miss Sun, she usually don't do it in this order. I don't know why she doing it. Left 3 is -3. Down 4 is -4. Okay, that's easy money, fam. All right. You see this? I can make you fill in the table, but that'd be real time consuming. Do you remember our OG table? This is the beginning. Square root of 0 is 0. Do you remember the original pattern? From the beginning, the square root of 1. Eyeballs, watch the way my pen moves. Square root of 1 is 1. From the beginning, what's the next one? The square root of 4 is equal to 2. Would you know what the next one is? From the beginning, the square root of 9 is equal to 3. And you give me a nice smooth curve for the square root function. And if you're drawing this by hand, you give me the blessing of an arrow. Ain't that gorgeous? Look at that good looking square root function. So now let's take care of domain. We go from left to right. So we're going to include the endpoint on the left side, and we're going to go to positive infinity. Range we know is up and down motion, but it's like building a house. You can go make your floor. Go hit that floor first. That's part of your endpoint. That's the lowest. It's like a minimum value. You raise it to your roof. You raise it high to the sky. And you go on and on and on. Now, how you know about this increasing, decreasing situation? Don't forget you give me the x values. Read the graph from left to right. Is this function increasing or decreasing? It's always increasing over the whole domain. So beautiful. And it never decreasing, so not applicable. Move on with our lives. Ooh. I want you to look at this one. I'm not going to spend too much time on this, but if you just want to, baby check, since we're on the video. What would be these transformations? Pause and write it down, and then I'm going to tell you the answer, okay? For this one class, I would do translation right 1 unit and translation up 2 units. Follow the OG pattern. But I'm going to leave this open and let you try it out for kicks. But I want to introduce you to other things. Check out this problem. If you write this down in your notes, leave a space and then bump it, okay? We're going to write down f of x is equal to negative square root of x. Look at this negative value. What is it going to do? Let's find out. Do you see how there's a negative in the front of everything? Okay? This is what are we making? Okay, make the y values negative. But if they're negative, you just change their sign. Positive goes negative, negative goes positive. All right? So you see, it's just a negative sign. So let's work with this. Let's start with the original square root pattern. I'm going to fill in my y values first, 0, 1, 2, 3. You know what the x values are now. 0, 1, 4, 9. I bet I could even ask you what the next one would be. It would be square root of 16 is 4. All right. So here, if I have the negative in the front of the whole symbol, that makes the y values go negative. So I'm going to just add in this negative sign. 0 positive or negative? 0 is in the middle. He's the referee. He's in the middle. This 0 is just 0. It's not positive or negative. So let's go ahead and graph this, okay? X is horizontal, Y is vertical. We got 0, 0, 1, 0, 4, -2. No space for the other one in a nice smooth curve from the beginning. Bam. Ooh-wee! Do you see what just happened? What did we do to the original function? I'll mark it in a light orange. This is where the original square root function was supposed to be. How did we change it? Did we translate? Did we bump this over and slide it? No. Doesn't this look like we kind of folded it over a line of symmetry? Doesn't this look like a mirror line like we've done in the past? But who is our mirror line? This makes a difference. Ooh, ain't that the x-axis? Look at you. So if we have a negative in front of everything, that means y values go negative. If you tell me flip, I'm gonna flip out on you. Don't you say flip. I want to see you use the vocabulary reflect over the x-axis. If you say reflects over the x, I don't know what you're talking about. No credit. Sorry. Do not pass go, do not pass to collect $200. Okay? Now the domain, side to side motion, slide to the left. How far to the left can you go? Before I answer this, what was the easiest question? We know what the endpoint is. 0, 0, Miss Stone. The origin. Now this domain, slide to the left. All the way to 0, we include the endpoint. Slide to the right. Forever and ever, that's positive infinity. How about this range? We know up and down. Middle confession. You must be careful. Many a classmate, they mess up on this. You build who first? Do you build the floor or do you build the ceiling? I'm curious. Did you by chance write down 0 to negative infinity? No! Sorry, no credit. This gives you nothing. Okay, we have to go from the minimum to the maximum. Gotcha. So we go hit that floor. How low can you go? Can you get down low? You can get down to negative infinity. That one has to come first. We go in order from least to greatest. Now raise it to your roof. How high can you rise? Gotcha. Check yourself before you wreck yourself. Now you want to think about it. Is this function increasing or is this function decreasing? You're reading the graph from left to right? From left to right. Ooh, we going down the slide. We decreasing, fam. And we know square root only gets one or the other. It's going to decrease over its entire domain. Decreasing, talking about the y values going down. So we got to talk about the x values. This whole thing is decreasing. Don't change. Quadratics can change it up. I like it. Gives a little variety, but this one's pretty straightforward. So in summary, what did this negative in front of the square root do? Ooh, reflection over the x-axis. Ooh, look at this. X-axis is on the exterior for the external, like an exit. Ooh, that's pretty cool. Shout out to Mr. Lee for that little memory device. But check this one out, friends. I give you another negative. But does the order matter where the negative lives? Yes. This time, who's the negative in front of? It's in front of the x, right? So now we have to make the x values negative. Basically, if it was positive, it goes negative. If it was negative, you go positive. We're changing the signs, okay? So use the OG pattern. Bless your heart. Make your life a little bit easier. If you remember this OG pattern, life is good. 0, 1, 4, 9. But this time, we see the negative is in front of the x, so you make all the x values negative. But negative x is just 0. It doesn't make a difference. So x is horizontal, y is vertical. 0, 0, negative 1, 1. Negative 4, 2. Ooh, look at the way that's turning out. Ain't that fancy? Ooh. Ooh. How do we transform this? I'm going to mark it up very nice and lightly. What the original used to look like. Is it dotted line or dash line because it's not really the one we're focusing on. Is this a translation? Not quite. Does it look like we're folding over something? Yeah. Ooh, you see that? We're folding, or don't you say flip. Don't you say flip. Don't you even think about it. I better hear that good vocabulary. Reflect. Over who? What's his name? What's your mirror line name? Over the y axis. Here you go. Here you go. Reflect over the y axis. All right, all right. Ooh, easiest point out of the 5 after you do this. This is pretty straightforward. Once you do this, the other ones fall in line. And point is origin, Miss Son, origin. Okay. Take care of the other ones. I'm not going to talk this time. I'm going to make you think though. Remember domain, we read the graphs from left to right. Slide to the left, slide to the right. And how do you know about how to handle this range? How low can you go? We hit them floor, hit that floor. 0 is included. We include our endpoint for square root. Now raise it to your roof. How high can you rise? Can you touch the sky? Yes. Class, let me tell you, we be messing up on this sometimes. Is this function increasing or is this function decreasing? Make a decision because I'm about to drop this knowledge on you. I hope you were reading this graph from left to right. I know this part looked like it going up, but we always reading the graph from left to right. Bam! It's always decreasing over the entire domain. Never increasing. Not applicable. Does not apply. Ain't that fun? This is a classic move. I would want you to know your transformations and the negatives. You gotta know that inside out. Go visit your Algebra 2 notes from then. So in summary, the negative is in the square root in front of the x, reflection over the y-axis like a book. Ooh, and they even look like book pages here. Ain't that fun? We're gonna call it a day with this one, okay? All right. Tell me what we got for these transformations. Wow, that's a fun way of using technology. Ooh, didn't we just talk about this? This negative, where is this in front of? This negative is in front of everybody. So who gets the negative? The y gets the negative, right? So if y values go negative, if they get the negative, we reflect over the other axis. So this means we're going to reflect over the x-axis. And how about this here? This +4 outside of the radical symbol. Bam! Translate up 4 units. Now, since we have this translation and all that stuff, and you know that there's a reflection over the x-axis, you can make the table, but if you promise to really know these transformations and not mix it up, you got to study it. You can't Google everything all the time. Data plans they're not always unlimited, friends. So if you know what to do with the situation, okay? We got a reflection, we got translate up 4. You can just follow the pattern from the origin. We're supposed to reflect, so it's going to go upside down. So we translate up 4 hops this time. 1, 2, 3, 4 hops this time. So our endpoint is, check yourself before you wreck yourself. X comma Y, give me the coordinate points in parentheses as an ordered pair. Now, if I reflect over the y-x-axis, the y values go negative. I'm supposed to be square root of 0, 0. I'm supposed to be square root of 1 is 1. But we're going upside down from the beginning, from your endpoint. The square root of 4 is 2, but instead of going up 2, we're going to make it go negative, and we're going to go down 2. Boom. So then my domain, you can pause the video and see if you can treat this like a practice quiz. Impress me. I'm going to quietly write it in and stop talking because I've been talking for an extra bit of time. Let's see if you got this. Pause the video and then click play when you're ready to check. All right, guys. I think you guys did a great job. I have a couple extra problems, but I think this is enough for today. So, in summary, what did we practice and review today? We worked on square root functions and we worked on transformations. Specifically, we worked on translations when we bumped it, shifting from left to right, up and down, and we've also talked about 2 types of reflections. Thank you so much for hanging out with me as a Sonester. I hope you have a blessed day.